there. So the title of our talk is essentially, it's actually a data, we're going to be talking about a data-driven approach to gaining operational efficiencies in load test environment. A little bit about myself. My name is Chanchal Gupta. I am Director of SRE at Edmunds. I'm one of the founding members and kind of helped introduce this discipline to Edmunds. My colleague, co-speaker is Simon Wong, who's been in this space for a number of years. He's got a lot of experience with incident change management and related areas. So on the topic, so we live in a continuous delivery and integration world requiring fast-paced delivery of features. Organizations need confidence in their ability to release code changes and features. You know, a release pipeline for web apps and microservices can be impacted directly or transitively with changes from each other, and this kind of requires the load test to play a key role like a line of defense in ensuring that you're not releasing defects or impacting services SLO. I know load test, when you think of it, is probably not the sexiest topic. For a lot of people, it's a little bit of it's on the boring side, because I wouldn't be surprised, it's something like someone set it up in your organization as operations, or somehow it's just there, and there is this assumption that it kind of works. But you'd be surprised, as we go through in this talk, like there are so many things you can do with, there's a lot of good stuff here, like you can improve upon. And thinking of, like, for example, load tests kind of play this global role, like they're like this global entity, at least in our setup. You don't have to have it, where they're kind of testing everything, all the microservices and web apps. And there is like, so by that virtue, they're kind of testing different services and artifacts for different teams. So there is an engineer who's working hard on performance features and things like that. And wouldn't it be nice if they could get more precise feedback before the release, before the feature or the service is released to production? So that's kind of, we're going to get into, in this talk. So how to leverage telemetry to provide visibility into your load testing system, and using a data-driven approach to ensure that the system is focusing on the most important resources. We're going to only touch a few aspects. There are several aspects to this. We'll primarily be focusing on the data-driven approach to looking at metrics. A little bit about the SRE team at Edmunds. It's a small team. Some of the areas we work on are website performance analysis, monitoring, alerting, incidents, and RCA. We are not a team that fits your typical mold of how it's kind of defined in the famous books / blogs. And part of it is we've evolved over time with the organization. I would say early on, when we started out, we were more closer to the definition several years ago. We are focused on web page performance. For example, we kind of try to link it back to the back-end performance. And I gave a talk last year which gets more into this if you're interested. And the reason for that is, as an organization, Edmunds, where we work, we value our customer greatly. So, the customer, the website user, And on that topic, Edmunds, I would say, is a medium-sized company. Our technology team is about 100 deep. We have offshore teams. We have microservices architecture and APM system in place. We've tried a few over the years, including industry-leading ones. And we are on AWS. Okay, that's a little bit of us and the team. Before I get into the talk, real quick on the photo. It actually is an upside-down car, just hanging in there in our office. It's the Edmunds office entrance in Santa Monica. It's actually a 2016 Chevy Corvette. It was installed in 2016 to commemorate the 50th anniversary of our company. It's kind of got to do with the founders. And above it actually is another car, which is a 50-year-old version. It's a 1966 Corvette, and they kind of move around slowly. It's kind of a nice place, although we are mostly remote. So, okay, before we get into the meat of the thing, I think I just wanted to give you an overview of the architecture. Real quick, I hope the slides are clear. I was here last year. I was hoping the projector is going to be a little bigger. They have actually a bigger projector. So if you can't see, maybe moving it forward may help. But yeah, hopefully it's, I'm mostly talking about stuff, so it'll be, good enough, I think. So understanding architecture at a high level provides kind of more holistic view of things, and which is kind of what you need when you're talking about something like a global service like load test system. So this kind of, I've kind of simplified the architecture a little bit here. So we have microservices. The user from a web browser hits the website, goes via CDN. We have a main website app, where web pages are served. And then there are a bunch of services, we have like tens or maybe even 20 services, which the backend may make call to fetch various data points. And then the browser may also request directly from a microservices, those so-called client-side calls. So that kind of, at a very high level, that's how most of the traffic comes in. And this plays a, if you are in an organization trying to take a look into your load test system, having an understanding at a high level, I think, makes sense. And this architecture, I believe, is a very common kind of an architecture, especially from pre-cloud days, where you had, even if you have different, but I think most of the concepts will apply. And also environments, we have two environments. One is production, which is where the website customer kind of, the website user is served from. And we have QA. Now, QA environment is not, it's a very tight environment in our case, because we have a CD/CI system, which is continuous delivery, continuous integration. So a commit comes in, there's a bunch of automated stuff that happens, qualification happens, there's canary qualification, and things kind of get automatically moved to production for the most part, for most artifacts and services. Now, and this is why for us, it's kind of super important that load tests are pretty, they are doing a good job because of all these automated steps. There's less human intervention and human testing. Most of it is an automated system. And things like canary qualification also, it's the same load that's serving all these things. Okay, one more, yeah, I think hopefully it's readable. One more, before, again, a little bit about the attributes. Now, when we think of a load testing system and what are we optimizing? So to get to that, we kind of need to build observability. Now, and I'm just going to go a little bit onto basic observability. How do you build, to get there? And I believe whatever organization kind of setup you have, especially if you are like on the smaller side, not a very, don't have, you still can get to basic observability. Of course, I'm not going to get into the whole topic, but real quick, just explaining it at a high level, just so it makes sense, and it's kind of super easy to do that, I think. And with a side tangent on like something the SRE team did several years ago, which is simple effort, which is kind of paying dividends, is, so continuing with the architecture. So I kind of introduced the diagram in the previous slide. So one thing I added is there is this web proxy, that orange box. So that guy is, web proxy is something like an Nginx or Apache, your web servers. They kind of play a pivotal kind of key role in traffic routing. So everything goes through them. They kind of route the traffic. They can also be thought of as a load balancer, although in the day of the cloud, load balancers have a more specific set of configurations, and they are a little different. But they're pretty robust sort of like systems, like Nginx, Apache, So this will, and one of the things they have in these web proxies is access logs. Now, taking a tangent, again, I think this is a very common type of an architecture. I believe, I think definitely pre-cloud, I think probably most of the sites had that. I think even in post-cloud, I think I won't be surprised, this is very common architecture. The point is, it's access logs and stuff is there. Even if they're not there, you can get to them. And what are access logs? They are like, if you go back to the early days of HTTP server, right, there was this Apache common log format. That's what I'm talking about, like, and they have various dimensions like, latency, request response time. So, so there's already a gold mine of data which can be used. We just need to establish traffic correlation, like who's calling what, who's calling whom and what. So just to go a little bit with tangent, so what we did a few years ago, the SRE team at Edmunds, we kind of took this and spent a little bit of effort in instrumenting all our services to emit a few set of common headers. These headers, it was bare minimal, and and what they did is they provided this visibility of who's calling whom and what. And, kind of creating the concept of grace. Although, yeah, at that time, I know open telemetry was not officially a standard. I think there were two of them. So we kind of rolled our own. I know right now it's the de facto standard, and some of you may be using that. And, so in hindsight, that was a great thing. The cost implications were very little. It was just the cost of storing a few extra fields in your access log, on top of what you're already storing. So yeah, so that kind of helped provide us this visibility. Now, once you have this correlation, what do you do? So in our case, we have a data warehouse pipeline. All this data is going somewhere, and we use Databricks sort of in recent years to analyze this data, and we're going to get into that, but you don't have to use Databricks or anything like that. In fact, the state of open source. Actually, that's a great idea to name this. Maybe.
Yeah, I think when you had it turned off earlier from up here, I think it'll be. There you go. All right. Yeah, I think this is better already, so I think we'll roll with this. Thank you.
Thank you. Oh.
Not anymore.
Not this one. There.
Stay there.
These are, they don't seem like LEDs. You can't dim them. Okay. So you don't have to have, so you may have an, APM or something in your organization. If it works for you, they are great, sophisticated systems providing all this telemetry. I mean, if it works for you from a cost and retention point of view, that's great. But you can build all these capabilities on your own. In fact, the state of open source tooling has never been greater. It's really awesome. There are things, I won't get into a lot of that. But yeah, so that's where we are. And I'm going to hand it out to my colleague, Simon, and he's going to walk us through how we utilize all this to gain some of the efficiencies around a Lotus system.
All right, you can turn that off. Thank you, Chanchal, for the introduction, and thank you for the high-level infrastructure overview. That's going to provide some context in the items that I'm going to review for the rest of the deck. And thank you all for attending, joining us, choosing us over an early green beer. It is St. Patrick's Day, so. So maybe we can take a step back and ask ourselves, why do we need to do load test, right? Load test is not free. I mean, we have to spin up resources. People have to support it. So show of hand, who actually likes production incident here? No one? One person. How about 4 a.m.? Do you still like it? Yeah. So imagine if 5 p.m. is okay. 4 a.m. no good. Unless you're, enjoy working in that kind of hour. I know I don't. So imagine if we had a user impacting issue, perhaps a latency problem that made its way into production because we didn't have a good load test system in place. Now your users could be is probably unhappy. Your brand and revenue is probably impacted. You might have a product guy pinging you all the time, wondering what's going on with the outage, when it's going to get recovered. That's never a good thing. So, and depending on the issue and the priority, you might have to put together a team. You might have to jump into a war room, and all those resources could be very costly. So we understand that even having a perfect load test environment in place is not going to prevent all incidents from happening, but we believe that it's going to help us prevent at least some user impacting issues from making it into production and help us maintain a performant website. So quick note is that the examples I'm going to go over are from Edmund's perspective. And we are a web company, so perhaps you might be from a different industry or you might have a different stack where a website might not be the primary service that you're providing to your end users. But whatever service it might be that you're providing, at the end of the day, what all of us are focused on is making sure that the users are happy and that when they're using our services, that they're having a good and pleasant experience. So as most projects and improvement efforts go, I'm sure you guys have all run into challenges, and we had a couple of major challenges when we started this journey. So first is that we needed visibility. So perhaps, again, it's not something that you guys might have a challenge on, but we, as Chanchal mentioned, we had all these data points and all the pieces that we needed, and even the mechanism to glue those pieces together using Trace ID. But we really needed a way to visualize it. We really did not have a visualization layer to show us what those data are telling us. So, and on top of that, even if we had that insight, we really did not have a process in place to optimize. So in the next few slides, we're going to show you how we gained the visibility that we needed and how we were able to address the issues that those visibility provided us, and how we eventually optimize using a data-driven approach. And quick note is that, even if you don't have these challenges, again, we hope that by sharing our experience with you, that you're going to get some learning, and hopefully some of those are things that you can take back to your organization and apply them. So before we begin, we need to, just like any other project that we work on, we need to ask what success actually looks like, right? So everyone here could be load testing. We have a lot of options out there in terms of paid services, open source services. You could set it up and start sending some loads there. But is the load test actually doing what it's supposed to? And in our experience, we were able to identify a number of key attributes that we needed to ensure a good and sound load test. First, we needed to make sure that we had good coverage. What we identify is that we needed to make sure that we have a good breadth and depth coverage. And those are two terms I'm going to go over. I'm going to use a number of times for the rest of the talk. So I will try to define them a little bit for you here. So in terms of breadth, in our case, we were asking ourselves, are all of our page types covered by our load test? And at Edmunds, our page types are organizational units where we group our URLs together and how we route traffic. So something like homepage is a page type at Edmunds. Perhaps when a user is looking at a particular car review, that is another page type. For some of you guys, if your product is a e-commerce site, the shopping cart might be a page type, or perhaps the item detail might be a page type. So the question we wanted to make sure we answer is, are all those page types at Edmunds covered? Now, in terms of depth, if those page types are all covered, are they actually getting the right load? And in an extreme example, imagine if we had 100 page types and 50 of them actually received the appropriate amount of load, and the other 50 got like one hit a day, right? So even though they are technically covered, that one hit a day for 50% of the page types really is not going to provide me data that is insightful when it comes to releasing builds successfully. So for a good load test, we also want to have proportionality. So the example I'll give here is that imagine if you had a handful of page types that received a ton of traffic in production. We want to make sure that as you're load testing in QA, that is also the case as well. You don't want to be sending a ton of load test traffic to a page that our production users are not actually using. And also, we want to make sure that it's low variability. So to give an example, in our QA environment, we actually have a continuous load. So it's constantly sending load test traffic there. Your environment might be a little different. You might have a setup where you're only load testing during a release cycle, but the concept that we're discussing for the rest of the talk here will still apply. For low variability, what it means is if you look at any website's production traffic, it's in a cyclical pattern, right? So there's peaks and low points in terms of traffic. The reason why we have a continuous load on our QA environment is that so we have consistency throughout the day. So if our developer needs to release a build at 10 a.m. or 10 p.m. or 4 a.m. when that gentleman is working, we can make sure that the load is consistent and predictable. So these are all kind of attributes that that we identify for a good and successful load test environment, and we'll get into them a little bit more in the next few slides. So now that we know what success looks like, we need the visibility. As I mentioned, we had a visibility issue when we first started this journey. When we first started, we didn't have an idea in terms of where we were. I mentioned breadth and depth. We really didn't know, where we are in terms of coverage for both of those attributes. Back in those days, we had to utilize our APM, start querying the access logs that we did have, and that was very challenging. It was cumbersome, and it was not very scalable. So to gain visibility, the team built a presentation layer utilizing Databricks. So for this talk, we'll try to refrain from going into specific technologies because we believe that it's a concept that matters. But so for this particular part of building the visibility, you could be using any data analytics tool to present the data in a meaningful way. So I kind of, before I share the insight that we gained, this is what helped us at Edmunds. So this is a view that I'll go over in a little bit more detail. Hopefully you guys have some similar report or has the ability to build similar reports to provide you guys with these insights. Basically use what's available to you, right, to gain the insight that's going to help drive the action. So a quick description here is that on the left side here, these are the page types at Edmunds. Again, you see home page on here, you see a number of article pages. These page type could represent one URL or dozens of URLs behind it. And you see 2 bars per page type, and that's because we actually built in a kind of before and after view here. So each of those bars represent a time frame. So as we're improving our load test traffic, we can see whether we're doing whether it's doing exactly what we're aiming to do. There's a red vertical line there in the middle, and that's a critical piece of indicator also. That represents 100% of our load test traffic. So in our QA environment, if all of our load is comparable to production, all those bars you see will be right up on that red line. Before I move on, I'll make a quick note about the scale of these graphs. These graphs are not in linear scale. If you guys could see, I know it's kind of tiny, but some of those top pages on top of the graph there has tens of thousands of % in traffic when compared to production. And if we use a linear scale, then it's going to create a visualized issue. So all the graphs that you're going to see for the rest of the talk, they are actually in log scale. Okay, so now that we have this visibility, let's tie it back to the attributes that we went over earlier. Specifically, in this case, the breadth. And as you can see from that graph, this is the fully zoomed out version of what you saw in the last slide. We had a major issue on the coverage of pages. So we had a very, very bad breadth coverage. You can see in that green rectangle that those are all the page types that did not have low test coverage at all. So if there's a feature or a change to a feature on a page that is within that green zone, it would not be covered and it would not get load tested. So as you can see, we were really not in good shape. But with this visibility, we at least have a very clear line of sight to understanding what we need to improve. So I think the takeaway here is that you need to clearly define what success looks like for your organization and create visibility that you might not have at the moment. And you want to be able to compare kind of a before and after picture as you are making improvements. So some of you guys might ask, with these pages not getting load tested at all, are bad code going out constantly? We certainly saw some incidents that went out that was pertaining to latency issues, and there's probably issues that kind of flew under the radar without us knowing so, just because we didn't have the visibility. But we still have functional tests. So as people are releasing code for these page types that were not getting load tested, things like end-to-end tests are still running on them. And another thing that when you guys are looking at this graph, one quick solution that might come to mind is, well, we could just spin up more resources and start throwing load at those page types that didn't have any. So that's one way of doing it, but as you can imagine, that could get very expensive very quickly. And the better approach, we thought, was to take some of those excessive load on top of that chart there and start shifting them and rebalance them to page types that actually did not have any load at this point. And that was the approach that we took. So some of you might, some or all of you guys might be in better shape than Edmund's was from the last slide, but there's also another aspect of having a good and sound load test environment, right? And we mentioned that earlier, and that is the depth part. And if you look at this graph, for the pages that were getting load tested, some of those top pages were getting way too many hits, and you can see that in the bottom there. Some of those pages on the bottom were getting less than a single % of coverage when compared to prod, and that is the depth issue that we were describing earlier. So our first goal at this point was to bring traffic into close to a production level. And as I mentioned earlier, hopefully you guys can see, there is a vertical red line there that represent production traffic. So the first goal is to bring all those bars on the top where, there's way too many hits to those pages, bring that closer to the center, closer to that red line, and the pages on the bottom there that didn't have enough load, bring those to the right and closer to the red line. So, and you might ask, like, is 100% of production traffic, appropriate? Maybe we're gonna have to do an exercise to look into that later, but this is kind of an iterative process, right? So we need to first get control first, and then fine tune and optimize later. And again, at this point, we wanted to bring everything closer to that red line. And again, we want to be able to do this, using a rebalancing type mentality and try not to add cost if possible. All right, so up to this point, we've been focusing on page types. What about our upstream services? As Chanchal provided an overview of earlier, our upstream services is tied closely to our web pages, where most of the traffic that goes to our upstream services are actually coming from the web pages. So if we're making changes to the tier that serves our web pages, we can expect things to change on the upstream services as well. So we need to make sure that we're mindful about how we're doing there in that tier as well. And looking at where we were before we started our improvement, you see that we also had a breadth and depth issue there as well. We had artifacts in our upstream services tier where they were not getting any coverage, and for the ones that were getting coverage, some of them did not have the right amount of load. So if you have a multi-tier architecture like we do, make sure everything is covered. That's the basic lesson to take away here. Okay, so after gaining the visibility to our status, we want to obviously you saw that we had major issues and we need to improve. So if you're like us and you did not have the visibility required, make sure you build that visibility, and then you should have a clear picture in terms of what to improve. So with that clarity in mind, for us at Edmund, we first set out to focus on improving our breadth. That is the green box there in terms of the page types that did not have any coverage at all. So what we did here was we analyzed production traffic, and we identified the gaps in coverage for things that were getting traffic in production, but they were not getting any coverage in our QA environment for load test. And we also did this while keeping in mind that we analyzed the upstream traffic as well, because as we mentioned, they're tightly coupled together. So kind of the before and after graph there, you see that we definitely improved drastically, focusing on just the breadth part of our load test improvement. The percent of pages that went, I know you guys probably can't see the page names, but the percent of pages that were not getting any traffic at all dropped from 70s down to the teens. And obviously, there's some more fine-tuning improvement to be made there, but for our first run, we saw great success there. And we were able to actually do this without incurring any costs. So what you're seeing there simply was to take some of those excessive traffic from those top key pages that had too many hits, and we shifted them to pages that, that were not covered at all. So now that we have better breadth coverage, that's only part of the attributes that we mentioned, right? So we need to also improve depth. And again, I don't know if you guys can see that color green, but recalling from a previous slide, we had, for pages that had too much traffic, we also want to shift them to pages that didn't have enough traffic. So this is where we also analyze the same traffic pattern in production, but this time with the emphasis on the number of hits that each URL actually required. And with that insight, we then updated the configuration for our load test, and you can see from the before and after picture that the depth part of the problem drastically improved as well. Now, again, 100% of production might not be ideal. We'll get to that in a little bit. But again, the first step was to gain control. And at this point, we had full control of, understanding our breadth and depth. We have the ability to visualize it. We are able to see it before and after picture. And again, we were able to do this without incurring any cost at all. So it might not always be possible. There are chances where, if you guys do this exercise on your end, you might have to spin up more instances on AWS or whatever platform you're on. But it should always be kind of something that you keep in mind, or even a priority during any kind of improvement or optimization, is to try to do it without additional cost or keeping the cost down. The other thing we want to call out is that, when we're doing these type of exercise, we all want to be able to prioritize on the right thing. As you saw earlier in the previous graphs, Edmunds actually has hundreds of page types, but only 30 of them made up about 85%, actually more than 85% of our revenue and page views. And the 30 or so page types are listed here. Now, you likely have, high value pages, or if you guys are not focusing on a web page, you guys might have services, key services that are more critical than the other. The point here is to emphasize the fact that we need to make sure we prioritize. So just a quick description of the table. For these 30 pages, the first column or the second column that you see that are completely red was how we were before we improved the breadth and depth of our load test. We were aiming for a goal of getting between 80% to 120% of a production level. And you can see that at that point in time, none of the pages fell inside that range. And then the middle column there, or the third column there, with a lot more green, is how we looked after we improved the breadth and the depth of our load test traffic in QA. And you can see that almost all of them fell into the range that we were targeting, right? So between 80 to 120% of production. And even the few that did not fall into that range, they were doing much, much better compared to kind of the before column there. So if you're in this kind of situation, make sure you know where you are. Make sure where your prioritized pages or services stand, and focus on those first. Okay, so far we've kind of showed you our work in improving coverages for our page types. Hopefully there were some takeaways there that you could take back to your organization and apply them. But what about upstream services, right? So we talked about that a few times because of how closely they were tied to our page types. We were hoping that by improving our web page traffic, that our upstream services would improve as well. And as you can see from this before and after picture, it actually didn't. So, obviously we had to find out why. So we performed analysis and took a look at the data, and what happened is we actually have a proxy in our upstream services that acts as a caching layer. And what happened was, because of this caching layer, if our URL variety, so different types, different path that we're testing in QA, if that variety was much lower than production, our caching layer, and as a result, our upstream services would not get hit as often, as much. So And that's the reason why by just improving our web page traffic, we did not see a comparable improvement on our upstream services. So we had to take additional action here. And most modern load test system provides the ability for you to decouple traffic that you're sending to different artifacts. And that's exactly what we did here. We basically specifically targeted the upstream services and provided improvement there. So it's a very similar effort to what we did for the web pages, but again, we just wanted to apply the same improvement on the upstream services as well. So as you can see, by sending the augmented connections and hits to these upstream services, we were able to see a drastic improvement for both the breadth and depth of our upstream services. I'm not going to spend too much time here. It's just showing you what was possible. Obviously, there are some top pages there that still had excessive calls. Again, that's something that we can fine tune later. But now we have a lot more control over the traffic that are going to the upstream services as well. All right, so everything now is under control, right? So QA is closer to production, is very, falling in between that 80 to 120% range. Now you might ask, let's go back to the question, is 100% of traffic in QA, when compared to production, is that really appropriate? Well, maybe it really depends on your organization and what your environment needs are and business needs. So that question is actually, that question needs to be answered as part of the optimization. So in order to optimize, we needed to first figure out what was the most efficient load test volume is, at least for Edmunds. So that's something for you guys to figure out what that is for you. But the critical part is you have to do this based on data. So at Edmunds, we performed an analysis on the historical release statuses and results and the latency of what the users were experiencing. And we identified a particular load amount in QA that we were able to release builds without impacting users, without generating incidents, and we considered this the baseline that we're targeting. Again, your baseline might be different. What's important is that you're performing the analysis based on a data-driven approach. So in our case, at the end of this particular analysis, we were able to set a goal of reducing QA load tests by 2/3. So, and before we actually move to reducing that load test, that continuous load by 2/3, we needed to confirm a couple more attributes that we talked about earlier, right? That is, whether or not our load test traffic is proportional and consistent. So this here in those graphs, we're actually visualizing the same load test traffic data, but from a different angle and different perspective. So this is a simple trend, a traffic trend of our continuous load for a given time window, but it is laid out in a fashion where the top chart there is the before view. I'm trying to show you guys how things look before we improved our load test traffic. The middle one is kind of the after view of after we made our improvement, and the bottom graph there is the same time frame of how our production traffic looked like for reference. So in terms of proportionality, if you focus on the color is kind of not very clear there, but the top line in production there, that's kind of a reddish line. If you focus on that line, you can see that in the before picture, even though it is the page type that received the most traffic in production, that was not the case in our load test environment. And if you look at the middle graph there, that was the after chart, how things look after we improve our load test traffic. You see that that page is now receiving the most traffic in QA as well, as expected. And if you look at some of the other pages, I know it's small on this small screen, but if you look at some of the other pages as well, you see that for the most part, everything is proportional to production. The other aspect is we want to have consistent load, right? So That is the low variability aspect of it. And as you can see from the before and after picture, even before we started improving our low test traffic in QA, the variability was already very low. That is how the, meaning that the line was fairly flat, so that if you are releasing a build, in any given window in that time frame, you are going to receive consistent and expected load there. So in the last couple of slides, kind of to summarize some things up, we use a data-driven approach to identify the most efficient baseline, again, for us. So for your organization, it might be different. We were able to build visibility that we did not have, something that you guys might have or might need to build. And we were able to identify that, at Edmunds at least, we could drop our load on QA by 2/3 and still have the same confidence in our build releases. So now we're at a point where we're comfortable in dropping our low test traffic by 2/3. And here, I'm just going to show you like additional kind of wins that we were able to attain on top of what you already saw when we improve our breadth and depth. This is more of a monetary win here. So when we lower the low test traffic in QA by 2/3, the number of, I think Chanchal mentioned that we're AWS shop, so the number of AWS nodes also dropped by 2/3. Now there are other infrastructure costs, obviously with AWS, like network costs, et cetera, but by dropping the number of nodes that are used in our QA environment by 2/3, that led to thousands of dollars in savings per month for us in terms of infrastructure costs. So to sum it up, we were able to improve our low test traffic in QA, and we improve our user experience. We help lower production incidents, improve confidence in our releases, and at the same time, we were able to save our business money. So we hope that you guys can take away some of the learnings here that we talked about and be able to apply them to your organization as well. But our effort doesn't stop there, right? So we really did not get into that bad state that you guys saw at the beginning of the presentation. I knew it looked very bad, but at one point in time, Edmunds, we probably had a pretty good coverage in low test. But over time, as we are making changes, as our website, the nature of our website changed, perhaps new page types gets released, some gets retired, the configurations were not maintained properly, so we drifted over time into that bad state that you guys saw. And we want to make sure that we don't, drift into that bad state again. So what we're planning on doing is we want to monitor and alert on any kind of gap in our load test. So for example, if we run into a breadth issue where page types that we expect to get load are not being load tested, we want to get notified. And if pages are getting tested, but they are not getting tested with the right amount of load, we also want to get notified as well. So and if we take action on those notifications, we would never get into that bad state again. And we also want to keep configurations up to date by performing the analysis that we did, that we shared with you, and the configuration updates in an automated fashion. So what we did here, a lot of it, so we built reports, we built tooling, but a lot of it is a manual process in updating those configuration. And we want to be able to take this POC and apply it so that we automate it going forward, and the configuration should stay up to date. So these process improvement will help us, stop the drift that got us into that bad state going forward. And again, hopefully you guys took away some of the lessons learned here, and we're hoping that it will be helpful to you as well. All right, guys, that is the end of our talk. Questions? We have a mic here. Yes, sir.
Hi, thanks. When you were talking about dropping the load traffic down, how do you know that it's still like statistically significant, you know, because if you go too low, maybe it's no longer representational.
Yeah, so so a couple of things. One is that because we did the analysis to build that baseline, we looked at a historical period of when a good state was, and we knew a certain amount of load in QA was appropriate to make sure that releases were still going out and that users were impacted. The latency was manageable and it was expected. Yeah.
So that's a good question, actually. That is the number one concern. On top of what Simon said, I think I'd say, so there were two approaches to it. One was we could use, I forgot the name, the statistical model that they use in elections and stuff, like, you know, to come up with statistical significance. But there was an alternate path, like Simon said, like we kind of went with, we had a successful baseline already, remember? Even though we had this not so great state for possibly months, we kind of took that baseline and we also built a model where we were evaluated, like in the presentation was a page types was a core concept. We kind of took it page type by page type. If we reduce it by 2/3, is the traffic similar, statistically significant, comparing it to production? So we kind of built that diff, and you know, it's like 80, 90, you know, I forgot the number, so it was kind of, that's how we arrived at it. But yeah, that is a key criteria when you do that, you know, and it's actually an interesting area also. We look forward to doing more work in that, so we can reduce our production. We have another thing in production, canary qualification on a tangent, so yeah, that's a.
I have a question. Was there a lot of transactional pages, and what was the performance there, or did you parse that out?
Not really. Admins is actually not at all transactional for the most part. Ours is, you know, we are a content website. I hope that's what you meant by transactional. Yeah. For the most part, majority of our traffic is content, like serving articles, pages, and you know, they have various faceting and searches, but all of them it is mostly view. So we have very little. There is some of it, but that's like little percentage of our traffic. Like, yeah. So that kind of simplified it. That's a good question. Otherwise, it's a little complicated job if you are taking post transactions or you know posts, HTTP posts and stuff like that. Although I think the approach would be in terms of prioritization and stuff, I think would be same. If we had that scenario, I would say building visibility and all that stuff.
All right, guys.
Oh, hold it. One more.
You're not allowed to ask a question.
So let's say you don't have historical data. The scenario I'm picturing is a new page type, and how would you determine high quality load traffic before rolling it out to a small number of users, or does that even make sense to throw engineering effort at?
That's a good question. So like I said, first we have an effort on way to further build this model using you know, a different approach. There were two approaches. But in your case, I think we've always had this approach. Remember, like the system was already there. So we can always take some, I think there will be some guidance from the team. So yeah, I think probably this is not the best answer. So we would still have like some guidance from the team and using production. I mean, if the question is really before even you get to production, yeah, that is a little tricky one. I think we'll have to make some, you know, assessment looking at latency. Right? One of the things I referenced there was, you know, the latency, you know, in the metrics of a key role. We didn't address that at all. Like, I think that's another thing we can take into, like, how much it is, you know, gonna have an impact, and taking some feedback from the, you know, product development team, you know, who are introducing this new page. Actually, that's an interesting one, because if it's not in production, I think the product development team will have feedback, because we don't have, remember this whole system works for production snapshots. So we take production, we do some, you know, calculations and, you know, thing, and take that snapshot and apply it to QA. Because it is a new feature, so there will be guidance from the production team, you know, as a starting point, and I think from there we can tweak it. Because we don't have any URLs, right? They have to tell this is the pattern, you know, these are like, you know, maybe 50 unique URLs, you know, is a good starting point. And yeah, I think.
Thank you.
It's a weird question for me, but I mean, where was your starting point? I mean, what did you go to, and you know, did you use any particular resources to sort of set out and fix this and get to a point where you could start to do things, or was this all homegrown?
Oh, you mean the actual solutions that we put together? Yeah, go ahead. So yeah, as we mentioned, a lot of the reports and functionality we built on top of Databricks. Honestly, they are just data that we already have, and we just did not have the ability to visualize it. And once we put together, and I guess if I'm answering your question properly, the reports, et cetera, that's pretty much all homegrown. But again, the underlying data has always been there. So, Chanchal.
Yeah, I think I kind of got into early when I was kind of presented into this, trying to answer some of the questions. It's all homegrown, in the sense, but it's, like I said, not to make it sound like something fancy. It's actually quite simple. I think any organization, you can do it. I mean, I suppose to motivate towards this kind of approach, you have access logs. That's the simplest thing, right, we've had. And you can build simple capabilities on top of it. The report we showed, we just kind of landed on this by, we had an engineer who worked on it. It just came out so awesome, like we thought it was a great way to quickly visually look at it and see the state of affairs, but that's not, like, you don't have to have that. So it's all, yeah, we have APMs and stuff, but I think this was all, like, homegrown stuff. Yeah, much easy to do.
I know we don't have a big audience, but like, I have a question for you guys is, who here has like as good a visibility or better than this? I mean, we never went out and compared it to our peers. Jeff actually, he's one of our colleagues, so that's the reason why I said, like, he can ask a question else. Just joking. All right, guys. Anybody else? Yeah, again, we didn't get into the technology part of it in detail, but feel free to catch us after to have some more in-depth questions if you guys want, or reach out to us over LinkedIn. All right, thank you.
Thank you, guys.